Okay, so the next topic is kind of different. It's called linear approximation or tangent line approximation or local linear approximation. They're all kind of the same idea though. So the idea is based off the equation of a tangent line, which we just discussed, okay? But if we want to rearrange this formula, well, if I want to approximate something, I'm approximating the y value. So if I add this y1 value to the right side, I will get this formula, okay? So see how they're very similar. The other way they might write it is because remember, slope is really my derivative, and they're just using an c value, which is really our x value anyway, okay? And then f of c, remember that is a y value. So you might see this formula, okay? But I like to use this one because it's not like you're memorizing something new. They really are the same. It's just a format. So since the value is an approximation, the approximately equal to symbol must be used in an AP free response question. If you write equals, then you won't get any point. Okay, and this would be 1 point on a free response, if that. Most of these questions are not calculator allowed because they want you to use this tangent line equation to get their value, okay? So we're not finding the value, we're just using an approximation of the tangent line to get it. So the idea is they're gonna give you questions like this. The square root of 99.4, the cubed root of 26. So these are values that you can't really do in your head, and that's the point. They don't want the exact values. But we need to find values that they are really close to do on our head, and then we can use that to notice the difference, okay? Because we'll be really close. That's why it's an approximation. All right, so let's look at the first question. Find the linear approximation of square root of 99.4. So what I do is I think, well, you know what? That's really close to the square root of 100. Okay, and so I could say f of x is equal to the square root of some number, all right, where we're using our c value, our point value is going to be 100, so if x is 100, then when I plug that in, the square root of 100 is 10, okay, and so that's my x1 and y1. But we know that this is really the x value. So I'm not going to put a subscript on that. Okay. So, and I know this sounds confusing. You'll get the idea in a second. So we get y minus, and I don't even remember to add that to the other side first. So I start off with the basic tangent line. And notice it says linear approximation. So this is your clue because we don't have another topic that's going to be similar to this. All right. So what I notice, let's use another color, that our point is 110. The x value that started is the original, so this is 99.4. Our slope, we don't know, but we can find that. So we've got f prime. Remember, we're going to change that to a power anyway, so 1/2 x to the negative 1/2, which is really 1 over 2 root x. And we want to use the value, even though I know that that's x, this is really confusing. We want to use the x value that we can do. So we're going to do 100. So square root of 100 is 10, so I would get f prime of 100 is equal to 1 over 20. And that's our slope. So y minus 10 . Okay. So then if I wanted to solve this, I could add 10 to the other side. And I can do this one pretty well in my head. So I get y is about 1 over 20 times, that would be negative 0.6 plus 10. And I know you think, well, really? Can I really do that? But yeah, I think you can. If you want, you can move this decimal one and then add a decimal place. So we really get negative 6 over 200 plus 10. What reduce, divide by 2, so 3 over 100. So negative 3 over 100 plus 10, which is like 9 and 97 over 100. And notice, if the square root of 100 is 10, shouldn't the square root of 99.4 be less than 10, but really close? Yes. So if you reverse some of these numbers, it should still work out. You might have switched the x and the x1, and so you got a number bigger than 10, but use some logic and check yourself. You know what I mean? I'd even cross those out, so on a test. All right, we're going to do the same thing here. So the cubed root of 27, I'm sorry, I said it already. The cubed root of 26, we don't know, but I do know the cubed root of 27. I'll do that all the time. Which the cubed root of 27 is 3. So that means that this is y1, this is x1, and this is x. Okay, so I kind of think of that. The one that you can do, that's your point that you're plugging in. All right, so y minus y1 equals m, we don't know, x minus x1. I should have plugged that in, sorry. 27, actually I will. X, so 26. And this one will be easier because it's not going to be a decimal, but I need to find my slope. So our function is the cubed root of x, which is really x to the 1/3. So our derivative is 1/3 x to the negative 2/3, which is 1/3 x to the 2/3. So remember, the number on top is a power because you're doing this by hand. The number on the bottom is the root. So when we plug in, we've got 1/3 times 27 to the 2/3. So I do the cubed root of 27 is 3. And then it's 3 squared, which is 9. So it's 1/3 times 9, which is 1/27. Okay? I know I just did a lot of math. So we get y minus 3 equals 1/27 times -1, and then add 3. So y equals, well, 3 minus 1/27 is 2 and 26 27. And once again, 26 is smaller than 27, so this should be less than 3. Oops, I forgot my squigglies. Okay. So why did you ever need to use this? Well, theoretically, there could be times back in the days where people said you didn't have access to a calculator in your pocket at all times, but we now know that's not true because we all have cell phones. All right, so that's basically the idea. If you want to keep watching, we're going to do a few more. Okay, so we're going to approximate, and I don't know why I picked all of these to be less. This could have been 3.01. It doesn't make it any harder. So that is kind of like 3 cubed. So f of x equals x cubed. That's our function. So y minus, I like to label these just for myself, honestly. 3 cubed is 27. So this is y1, x1, x. So y minus y1. I don't know my m yet. X minus x1. So f prime is going to be a power rule. F prime of our nice number is 3. Oh, that's a coincidence. And it's a coincidence that that's 27. Okay. It's because we're using 3 and the power rule and stuff like that. All coincidences. So y equals 27 times negative 0.01, which just moves this over 2 spaces, plus 27. So negative 0.27 plus 27 is equal to about 26.73. That's our approximation. All right, approximately how much less is 4? Less than 4 is root 63. So we're going to find what the approximation is and approximate it. There could be shortcuts. I don't know. I just don't use them. So we're comparing it to 4. So I've got the cubed root of 64 is 4. So this is y1, x1, x. So y minus y1 equals mx minus, I always do this. I don't know why I don't sometimes do that right away. Okay, so f of x is equal to the cubed root, our derivative. I feel like we did this, but we did. On number 2. So if I plug in 64, so the cubed root of 64 is 4. 4 squared is 16. So 1 over 48. Which, boom. That's what we're going to end up doing, but I'll show you. So y equals 1 over 48. This would be negative 1 plus 4. So we're going to end up subtracting that 1 over 48. Okay? So did I really have to use the tangent equation if I understood it was going to be my slope and what my new x value was? No, of course not, blah, blah, blah. All right, so let's look at our next example. We've got 630, and they tell us the derivative is equal to that, and we want to estimate 6.02. Okay, so we know this is x1, y1, x, and we know our slope. So I'm going to do f prime of 6 and plug that in. So 6 plus 3, so what's that? 36 over 9, so 4 is our slope. So y minus y, m, x minus x. And so see how we can word it so different, but it says to estimate using the tangent line. So that's kind of trying to tell you to use a tangent line approximation. Okay, so y is equal to 4.02 plus 30. So 0.08 plus 30, 30.08. Yay, I love it when it matches up. I haven't done this for years either. Okay, looks like we have 2 more. All right, so number 6, the linear approximation. So we want to write the tangent line approximation. So near pi over 4 is based on, well, we know it's x minus x, which they all have that. So I'm just looking here. I need to find the slope. So if f is equal to tangent, I need to know the derivative. So the derivative of tangent is secant squared, which is 1 over cosine squared. And we're plugging in pi over 4. Okay, so you have to remember pi over 4 is a 45-degree angle, 1 root 2. Cosine is adjacent over hypotenuse, so 1 over root 2. So 1 over root 2, and I'm not going to rationalize this because we're going to square it anyway. So 1 over 1 squared is 1, root 2 squared is 2, 1 over, multiply the reciprocal, is 1 times 2 over 1, which is 2. That's my tangent slope. So y minus y equals mx minus x. So our slope is 2. X minus pi over 4. I know I'm going to add y, so I need to find the y value. So the tangent of pi over 4 is the y value. Well, tangent is opposite over adjacent, so 1 over 1 is 1. So don't see a 2, don't see a 2, don't see a 2. Here we go. D. All right, I've got 20 seconds left on this video. I'm going to run out of time. So I'll probably make a part 2 for this, but I'll start talking about it anyway. This is the derivative graph shown. This is my y value, so x y, then the local